Assalamualaikum warahmatullahi wabarakatuh, and a very good day to anyone who's watching this video. Thank you for spending your time to watch my presentation. My name is Yasmin Adlina Izzati binti Muhammad Noor, a final year student from UiTM Shah Alam, and today I'm going to explain to you my final year project, which is the hand gesture recognition system using continuous wave radar based on hybrid PCA-KNN. So in this presentation, first I will be explaining the introduction, dataset description, the methodology, and then proceed to the result and discussion, and lastly, the conclusion. So we start off with the introduction. In the past decades, technology has continued to grow efficiently for various users. The HCI, which stands for Human-Computer Interaction, is a field of study that focuses on the interaction or communication between human and computers. The keyboard, mouse, and joystick are typical examples of contact-based HCI machine. Although they are very successful in many applications, in some cases, their use is limited. For instance, in a surgical place, modern surgical procedures involve interaction with computers, but such things as keyboard and mouse can be a breeding ground for various types of bacteria. Thus, hand gesture can be used as a solution to this problem. There are many hand gesture research out there with various sensor used, such as camera, ultrasonic sensor, and radar. Cameras have shown their effectiveness, however, they are very sensitive to the surrounding light, incapable to detect through an obstacle, and can cause a privacy issue. The second method would be the motion-based sensor. It can digitize hand movement into a multi-parameter data by relying on the gyroscope. It is also easy to collect the hand gesture data with additional sensor, but due to the circumstances, it can be expensive and complicated to operate. This is why we decided to use radar as our sensor in this project. Unlike camera, radar can preserve the anonymity of the user and are less expensive compared to the ultrasonic sensor. As stated before, radar has been chosen as the method to detect the hand gesture. However, there are many types of radar used, and the problem found is that the current radar-based hand gesture solution is expensive due to first, the expensive hardware such as FMCW radar and pulse radar. Second, the expensive processing system such as neural network and deep learning. A lot of hand gesture recognition systems found use both of these expensive solutions. So, we propose a solution. That is to develop a low-cost radar-based hand gesture system. So how we develop it? We develop it by using a low-cost radar, which is the continuous wave radar, and a low-cost signal processing, which are PCA and KNN. This project will be focusing on the usage of CW radar and the signal processing done to classify the hand gesture. As our scope of study is only limited to signal processing, our objective is to investigate the use of PCA, which stands for Principal Component Analysis, and KNN, which stands for K-Nearest Neighbor, based combination for classifying hand gesture. To explain in detail, the first objective is to extract the features in frequency domain. Then, reduce the features dimension using PCA, and lastly, we classify the hand gesture using the KNN based on lift-one-out procedure. Lift-one-out procedure is a statistical method for randomizing data for training and testing of classifier. So now I'm going to explain to you how the hand gesture data was prepared. There are 4 different hand gestures in total. The first hand gesture is swiping from top to down. Straight hand position with palm facing the radar, then swipe down. Second hand gesture is swiping hand from right to left. Hand on the left side with palm facing the radar, then move to the right and back to starting position. The third hand gesture is clenching hand. Straight hand position, then do a fist bump pointing at the radar. And the last hand gesture is clenching hand with a 90-degree rotation. Straight hand position, then grip the hand with a thumb pointing at the radar. The subject used is a single subject, which is a 24-year-old male. The data was collected using a continuous wave radar, where the transmit frequency used was 2.4 GHz. Each hand gesture was repeated 200 times, with a 2-second delay between each sequential hand gesture, making a total of 800 samples collected for all 4 hand gestures. Each gesture was conducted with almost consistent velocity, and the surrounding was cautiously secured from the unwanted movement, which can be presented as an unwanted signal or noise. The spectral data of each hand gesture are depicted in the figure below. From the above, from the first line is the second hand gesture, second line is the first hand gesture, the third line is the fourth hand gesture, and lastly, the last line is the third hand gesture. Based on the spectral radar, we can see the difference of each hand gesture. So we move on to the methodology. First, we started with the dataset preparation. We obtained the data as stated in the previous slide. Then, we proceed to power spectrum transformation, where we change the domain of the data obtained for deeper analysis. From time domain signal, we transform the data into a different spectrum data known as frequency domain signal using fast Fourier transform (FFT) technique, where the spectrum represents the Doppler components contained in the received signal. The performance of a classification system is determined by how the target is defined by the feature vector. The FFT-derived spectral feature vector has a high dimensionality and the features are highly linked. Principal component analysis (PCA) is now used to reduce the dimensionality of the spectral feature vector by leveraging the correlation between the features. In theory, PCA captures the linear relationship between the features of a hand gesture. It compresses the attribute space by identifying the strongest strands in the data, and the result of PCA is then used for classification as either training or testing data. In general, a conventional method in classification system is to have two distinct phases, which are training and testing. In the training step, a model for each received hand gesture is constructed using the training dataset, but in the testing stage, a PCA-based feature vector is produced from an unknown received hand gesture. However, due to the limited size of the database, which are 800 samples, all hand gesture signals were used for classification tests in this paper rather than dividing the database into training and testing. Then, to make it more realistic, a leave-on-out procedure was used, in which only one hand gesture signal was used for testing at a time, while the rest remained for training signal. The classification system might be based on either modeling the distribution of features for each class or on class discrimination. There are two ways that can be used. First, discrimination-based, and second is the modeling-based, which is either parametric or a non-parametric model of the distribution. Both the discrimination-based approach and the parametric modeling approach have advantages such as greater accuracy and smaller asymptotic error, but both require a significant amount of training data. As a result, a non-parametric technique, especially the k-nearest neighbor (KNN) classifier, was used in this work. Despite its simplicity, KNN is a highly effective pattern recognition algorithm. The distance between the testing feature vector and all of the feature vectors associated with the training model is then computed. The test data is sorted into a hand gesture category, which is the most common among its k nearest neighbors, where in this paper k is set to 3. The optimal choices of k in KNN is dictated on the data. Generally, larger values of k reduce the effect of noise on classification while making class boundaries less visible. If the assigned group and the actual group of the test data match, the classification is termed as successful. So we can proceed with the result and discussion. This figure shows the power spectral density computation of hand gesture signal via FFT algorithm. Each of these plots contains 200 superimposed PSD, and from the graph, we can see that the data has been cut to 50 Hz. 50 Hz means 50 features of the hand gesture has been chosen. The reason the data has been cut to 50 Hz is because larger data cannot be calculated by the computer. The second and third figure shows the result of PCA feature reduction. As we know, the function of PCA is used as data pre-processing to reduce the data dimensionality. The extracted feature of a hand gesture using PCA is known as principal component. PC, and these PCs are ordered in such a way that the amount of variance explained by each PC is not increasing as illustrated in the first figure. The statistic in the figure show that both PC1 and PC2 reflects the greatest amount of variance in the data, which is more than 95%. This shows that this 2 PC is sufficient to represent the information contained within the data, as we can see from the second figure. The plot shows that the different hand gesture is clearly separated between each other, where the blue hand gesture indicates gesture 1, red is gesture 2, black is gesture 3, and pink is gesture 4. Each gesture are separated with considerable distance with each other, indicating a high accuracy for classification. The fourth figure shows that the result of classification using KNN. The training and testing of KNN was conducted via leave one out procedure. The average error of the model is calculated and used to evaluate the classification system performance. As the assigned group and the actual group of the test data match, the confusion matrix shows that the PCA and KNN can classify the hand gesture with 100% accuracy. So, to conclude, in this work, we have presented the feature extraction in frequency domain, feature reduction using PCA, and classification of hand gesture using KNN. The work have shown a promising result which indicate a 100% classification accuracy and proof that the low-cost radar-based hand gesture system is indeed viable. That is all from me. Thank you once again for spending your time watching my presentation video. Stay safe and Assalamualaikum.